going to discuss a sample problem about the thermodynamics and heat transfer. This is in Chapter 1, Basic Concepts and Definitions. Okay, and here's the sample problem. A building's height can be determined using the fundamental barometer. Calculate the height of a building if the barometric pressures at its top and bottom are 750 and 785 mm respectively. Assume that air and mercury have densities of 1.18 kg per cubic meter and 13,600 kg per cubic meter respectively. So as you can see here, we're gonna use this mercury to get the building's height. Okay, let's proceed to the given listed below. Here are the barometric pressure at the top is equal to 750 millimeter. So this millimeter is converted to meter, so we get this 0.750 meters. And the same as the barometric pressure at the bottom, 785 millimeter is converted to 0.785 meter. So the density of air is given to be 1.18 kg per cubic meter and 13,600 kg per cubic meter for the density of the mercury. Okay, proceeding to the solving for this to get the atmospheric pressures at the top and the bottom of the building. So this is pressure is equal to the density times gravity times height. So the density of the mercury is 13,600 kg per cubic meter times to 9.81 meter per second squared. So this is the acceleration of the gravity times to the height. So the height is 750 millimeter. It is converted now to meter, so it became 0.750 meter. And by this, we have this conversion to Newton, and then by converting to Newton and converted to kilopascal. So here are the conversions, and then calculating all these numbers found in this equation, and then we'll have this final answer 100.06 kilopascal. So as the same as the pressure at the top, okay, let's calculate also for the bottom. So we'll get this 104.73 kilopascal. In this, taking an air column between the top and the bottom of the building and writing a force balance per unit base area. So we have here, we obtain this equation, and then this is equal to the density times gravity times height of the air. So this equation, we're gonna use this equation to get the building's height, and then substituting all those numbers we solved earlier at the previous slide, and here is the conversion of the Newton and into kilopascal. So it is also present here, okay, and then the change and the P bottom, the subtracted to the P top, and calculating. So here is the height of the building. We have 403.43 meters.